My name is Evan Smith. I'm a junior at Northside High School, and this is my pitch. So what I have here is my problem is oil spills. Oil spills are detrimental to society, environments, and economies as a whole. And as a child, I always thought, why can't a community of the earth just come together and solve this obvious and dangerous problem? And I went through and researched extensively on the strategies currently used on picking up oil. And I was very disappointed by the results. There's strategies like skimmers, there's strategies like burning the oil and introducing bacteria into the water to eat the oil. Skimmers are very situational. The conditions have to be just right, the weather has to be just right, and that's just not how the world works. It's always raining, it's always windy somewhere. And then burning is just very dangerous in general, and bacteria is dangerous because you're introducing a very aggressive bacteria into a new environment. So I started to think of natural materials to just come together and soak the oil, and my first thought was cotton, because I just knew cotton was very absorbent, and I was proved wrong by my research saying that cotton is very hydrophilic and it will take the water over the oil anytime. And I came upon this one article about this awesome material called basalt fibers. Basalt fibers is a mineral material used in construction to strengthen and to waterproof asphalt and concrete. And I think this is a really cool thing. So I made a gravity-based filtration system. This is charcoal, gravel, sand, salt, and the way it works is you just put a simple intake on top where you can just even scoop it into the contaminated water, and it flows down with gravity, and it just goes through the salt and it works. With my experiment, I experimented with this specific prototype you see here, and I found with gasoline, it picks up, with varying volumes of gasoline in water, it picks up around 82.5% of the oil each time. And with synthetic oil, I did the same thing with varying volumes in water, and I found that about 91.5% of the synthetic oil was picked out of the water. The cool thing also about it is after you're done with it, the basalt can be recycled into the asphalt and concrete it was originally intended for, and the oil, up to 95% of the oil can be reused. It can be soaked out and everything. This moves on to marketability. Well, that moves on to my improvements I made. I originally had this as a metal, but then I found that it would corrode easily, and that just wouldn't work. So plastic would work better. And also I found out that the density is not the goal here. The surface area is the goal. So longer salt fibers with less packed in, more surface area. That moves on to marketability. Marketability is anyone that is willing to help. I can go from environmental engineers to just a loyal servant to local government that's willing to help out. So anyone willing to go out of the way or already on their way to contaminated water sources can go out and help pick up and feel gratified that they're actually doing something for the environment. And also, this is actually a scale prototype rather than it still works, but it is a scale prototype. Because I originally intended for larger scale, like installing into dams and skimmers, so that way it can have a larger impact on a larger area rather than just small streams and lakes. That it's just very environmentally friendly, it's very recyclable, it's very effective in everything it does, and I think it's a great product.